Welcome to this class. This session, we are going to introduce the concept of relations and functions. Relations and functions. So the first thing, we are going to define what we mean by a relation. So relation is a set of ordered pairs. So that's how we define a relation, a set of ordered pairs. And then the domain of a relation is the set of all first members of the ordered pairs. So that's how we define the domain of a relation. And then the range of a relation the set of all the second members of the ordered pairs. So the range of a relation is the set of all the second members of the ordered pairs. And lastly, let's define what we call the graph of a relation. The graph of a relation is the graph of all ordered pairs of the relation. So those are some of the definitions. And then the next definition, a function is a relation such that, or a relation in which no two distinct ordered pairs have the same first element and different second elements. So that's what we call a function, a relation in which no two distinct ordered pairs have the same first element and different second elements. So let's, after giving the definitions now, we can give some examples. So if we have A, comma B, A, comma D, 1, 3, 1, 4, and say 6, 3, 8. This is an example of a relation. B, if I have the set 2, 4, 1, 8, minus 2, 8, 4, 9, 1, 100. This another example of a relation. If I have C, 1, 3, 4, 8, 2, 9, 6, 7, 9, 10, A, comma D squared. This is an example of a relation. If I have D given by 1, 3, 4, 8, 9, 10, 2, 2, 1, 3, or say 11, 13, 4, 8, this is also a relation. And if I have E, 6, 8, 9, 3, 4, 8, and 9, 10, this is another example of a relation. So all these things I've listed here are relations. So examples of relations. Now, say example 2, graph the following relations. So the first relation A, 0, 4, 1, 3, 1, 8, 1, 4, 2, minus 3, and say 4, 5. So this is the first one. So 1, 4. So this is what you do. You just draw the normal XY plane. Label the axis 0, -1, -2, -3, -4, -5, -6, -7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. -1, -2, -3, -4. So once you have drawn the XY plane, now let's identify the points. 0, 4 means X is 0, Y is 4. So this will be the point. So this is 0, 4. And then next point is 1, 3. So 1, 3 is this point here. Next point is 1, 4. So 1, 4 is somewhere here. So this 1, 4. 2 minus 3. 2 minus 3 is a point here. Then 4, 5. 4, 5 is here. This is 4. Then along the Y. So 5. So somewhere here. They're simply plotting points in the Cartesian plane. So that's the end of that. If I have relationship B, relation B, 0, 4, 2, 3, 1, 1, 4, 5. So similarly, you draw the XY plane. Zero, -1, -2, -3, -4, -5, -1, -2, -3, -4, -5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. Then we plot the points. So 0, 4, this point here. 2, 3, 2, then 3 will be here. 1, 1 is the point here. 4, 5 is this point 4 on X, Y, 5. So this is 4, 5. So that is how we graph the relation. Example 3. Which of the following relations are functions. So let's have the first one. A has 1, 2, and then minus 1, 3. Then we have 0, 6. Then we have minus 7, 5. B, we have 6, 3, and then minus 2, 1, and then 5 minus 4, and then minus 2, 8. And then C, minus 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. So let's discuss this first. So to know if a relation is a function, then we have to check all the pairs in the set and see that no two distinct pairs have the same element, this first element, and have different elements in the second position. That's how we define a function. That a function is a relation in which no two distinct ordered pairs have the same first element and different second elements. So the key thing is to scan through the first elements of all the pairs. And if you are able to show that there is no pair that has the same element at the first element and having different second elements which are different, then that will be function. Otherwise, if we have distinct pairs with the same first element but different second elements, then that's not a relation. That relation is not a function. So in the first one, 1 minus 1, 0 minus 7. So because all the distinct pairs have different first elements, then automatically this becomes a function. So this is a function because all the first members in each pair are different. B, we have 6 minus 2, 5 minus 2. You see there's minus 2 here and there's minus 2 here. So we have two distinct pairs which have the same first elements. But then this second element of this pair and this second element of this other pair, they are different. So because this set has two distinct pairs with the same first elements, but different second elements, then it's not a function. Not a function, since two distinct ordered pairs minus 2, 1 and minus 2, h have same first element but different second elements. So that's not a function. Now in C, the first elements we have negative 1, 0, 1, 2, 3. All the first elements are distinct. So therefore that becomes a function by default. So don't get confused by you see here, second element is 1 and here is 1. So second element being the same does not disqualify the relation to be a function. What could disqualify a relation to be a function is to have in each of the, to have two distinct pairs with same first element but different second element, not the second element. So this is a function. So that is how we identify functions from relations and how we sketch or graph relations and how we give examples of relations. The next session will be now discussing how to find domain and range of relations. Thank you.